All right, so today we are looking at different kind of linear graphs and we are going to be interpreting them as best we can. Okay, so this first part is just kind of a big long example. First question, when is the mountain climber's height increasing the fastest? Okay, well the fastest would mean that, right, as time is passing, and remember time is this x-axis, as time is passing, his vertical change is going to be the steepest. Okay, it looks pretty steep right here, and it also looks pretty steep right here. It also looks pretty steep right here. Okay, now we can cross this one off because it says increasing. His height is not increasing at that point, right? It's decreasing because we're going back down the mountain here. But in these two spots, we've got some good increasing happening. I know that this is actually going to be increasing the fastest because you see how both of these span 2 blocks, right? 2 units on my x-axis, whereas this one goes up 3 while this one goes up 4, right? So I know that this second one is increasing the fastest because they both span 2 blocks, which in this case is 20 minutes. All right, so we're going to write the time from 60 to 80 seconds. Minutes. All right, when is the mountain climber's ascending up the slowest? Okay, so we're assuming that he's still ascending. When is it going the slowest? All right, well here he's totally flat and here he's totally flat. We're going to assume we're not talking about those points, right? We want to assume he's still ascending a little bit, which means I've really only got this point right here to look at. Okay, so I'm going to say he's ascending, right, still climbing up the slowest from 30 to 60 minutes. All right, when is the mountain climber's height not increasing or decreasing? We kind of just touched on those points a second ago, right? The times when he's not increasing or decreasing are going to be right here when it's totally flat, and right here when it's totally flat. All right, so this first section is going to be from 20 to 30 seconds. Minutes. 20 to 30 minutes. And from, let's see here, 80 to 110 minutes. Now, a really important question here. What are possible explanations for these time intervals? It's really, really important to understand, you guys. He's not moving at a constant speed here. No, time is passing and his distance remains the same. So that means he stopped. So any reason that would cause a mountain climber to stop, he needed a rest, he needed to tie his shoe, whatever. Right? He is stopped. Time is passing, but his distance is not changing. That means he is stopped. When does the mountain climber start his descent? Right? How does he go down? I'm thinking that's this point right here, right? And that's at 110 minutes. How do you know? I'm going to say the slope changes. Or slope starts decreasing, becomes negative. And last but not least, how long did it take the mountain climber to climb to the mountain and return? Okay, so he starts climbing the mountain, right? Climbs the mountain, again comes back. We're talking about the whole graph here, right? So we're going to say 150 minutes. Okay, how do I know? That's the time from start to finish. So now after we've kind of had a brief intro explanation here, I want you guys to go to your other paper and we're going to talk about a couple of choices. So I've got a few different choices here. The first, and I've got 2 questions you can see. These 2 situations match 2 of these graphs. Okay, so there's one we're not going to use. All right, option 1. Katie walked from home to the library, did some homework, then walked back. So we're talking about distance from home and time. So this would be time, and this would be distance from home. For all 3 graphs, we're going to see which one works. Okay, well, if time is passing, her distance, and she's going to the library, okay, her distance is increasing away from home, cool. Did some homework. Okay, then we got flat. That's good. Then walked back. Well, if we're walking back, her distance from home should be decreasing again. So it should be doing this. Hey, you know what? That looks exactly like our next graph. Okay, so we figured out that this last part then walked back. Her distance from home should go back to 0, right? So that's got to go back like this. So we're going to say choice B. All right, let's go ahead and let's look at our next situation. Katie was driving and sped up to get on the highway. Then she got stuck behind a truck that was driving at a constant speed. The truck changed lanes and Katie was able to speed up again. So we're talking about speed and time. Remember, guys, time goes on the bottom. So time versus speed. Okay, so it says she was sped up to get on the highway. So the first thing we should see in the graph should be her speeding up. Okay, that works. So does this. This last one here, we kind of are starting off at a constant speed, so that's not working. This right here is not speeding up, right? So we're going to cross this off. All right, and then it says she got stuck behind a truck that was driving at a constant speed. Okay, now the flat area does mean a constant speed, right? Because our y-axis is speed. And finally, the truck changed lanes and Katie was able to speed up again. Okay, so her speed is increasing again. This doesn't make sense in this situation, right? So this has got to be option A. Okay, so kind of the biggest difference is you guys need to be able to tell is when you get those flat parts, does it mean that the person in this situation has stopped, or does it mean that they are going at a constant speed? Guys, the answer to that question relies completely on, well, what's on that y-axis, right? What's on that y-axis? That's how we are going to answer that question. Okay, all right. Let's see, we've got the next problem we're talking about Teddy, and then I'm going to give you guys kind of an opportunity to practice, okay? All right, Teddy lives 8 blocks from the school. The diagram at the right shows Teddy's route from home to school. The drive only takes 7 minutes. Below the diagram are 2 graphs corresponding to one of Teddy's trips to school. The first shows the speed of the car as a function of time. So guys, we're saying that here is the situation. This is his route to school. All right, this graph right here is mapping his speed compared to the time. And the one on the bottom is still the same situation, but this is mapping his distance according to time. All right, here we go. And notice how many stop signs and lights do we have? Like these are kind of our critical points here in the graph. All right, let's read. Assuming he obeyed the law at all times, did Teddy have to stop for any lights? Okay, well, if he stopped, I like this graph the best. Did he have to stop for any lights? All right, well, let's look and see where he did stop. He stopped here at about 1 minute. Well, there's a stop sign right next to his house. Like, you have to stop for a stop sign, guys. I don't know if you know that, but it's the truth. It's the truth. That's the law, right? Gotta stop for a stop sign. So this must be a stop sign right here. Okay, then he stopped again. And that's got to be another stop sign because look at this graph up here. Do you see how we have another stop sign right after his house? Okay, and then we have 2 lights in a row followed by that final stop sign. So where is his next one? Okay, we've got another one up here, but we know there's a 3rd stop sign, guys. He stopped 3 times and he only had 3 stop signs. So did he stop for any lights? Did he stop here? No, right? 3 stops. Those had to be the stop signs, right? Because you have to stop for those. You don't necessarily have to stop for a light. Just depends on your luck. Okay, next question. When was Teddy driving the fastest? Okay, so for talking about speed, when is he driving the fastest? I'm going to look at this graph that maps his speed, right? So let's see here. It looks like in about half a second, he got about up to 10 miles per hour. Then it looks here in about another half a second, he got up to 15 miles per hour. All right, you guys, here, how long, let's see, how long did it take him to get up to that maximum speed? From here to here, that's about 1 second, and he's going 30 miles per hour. So I would say that this, right, is when he's traveling the fastest. So I'm going to say between 2 to 3 seconds. All right, because that's when I have the greatest change on my speed graph. Question 3. How can you tell from the second graph when Teddy's speed is 0 miles per hour? All right, we already kind of talked about that, right? If it's 0 miles per hour, that means that he's stopped. So on the second graph, on this graph, we see horizontal lines in the graph. Okay? Describe Teddy's trip, refer to the graphs in the diagram. Honestly, I like this one the best, right? He left his house, he got to school, only having to stop at the stop signs. Okay? You might talk about here, you can tell, okay, that must be the first stop sign, that must be the second stop sign. Then he must have been speeding up to school, maybe he had to slow down, he got stuck behind somebody that was going a little slower. Or maybe he went to a school zone, right? Sped up a little bit, then he had to stop again for that last stop sign. Speed up a little bit, and finally finish being at school. All right, so again, guys, today's lesson is just being able to look at a graph and interpret it. Okay, I'm going to give you a little bit of time to look at these last ones. All right, and we are going to get practicing.